Hello everyone, today we'll be going over Chapter 6, otherwise known as Normal Probability Distribution. Here's an outline for this chapter. It is broken into two parts. The first part is a basic application of z-score theory and its formula, and the second part is special cases, which include the probability between 2 points, using z-score in combination with other probability rules, and lastly, percentiles. Here we have a brief summary of the theory of normal probability distributions, otherwise known as continuous distributions. Z-score theory is based on the following 5 equations, the first of which is mean, otherwise known as average, median, the middle value of your distribution once you put the values in ascending order, mode, the most frequent value in your set, your standard deviation, and lastly, we have the new equation, which is the z-score equation, which is simply any x value subtracted by the mean and divided by the standard deviation to give us a z-score, which we will learn to use shortly. Here's what the distribution looks like. It is a bell-shaped curve that is split exactly in the middle by the mean, median, and mode, with 50% or 0.5 of the values laying on one side of the split and 50% of the values or 0.5 of the values on the other side. Here we have a z-score table which is used to translate the z-score into a percentage. The z-score formula gives us a value normally within the range of -3 and +3. Once you have that value, you would go look it up on either table, the positive table or the negative table. For example, let's say we had a score of 2.74. Since that score is positive, we will go to the positive table. We will begin by looking at the first column and finding the column that matches 2.74, which would be this row here, the 2.7 row, and we would move in that row to find the column which matches exactly to 2.74, which would be right here, meaning that the value that corresponds to our 2 points is our percentage. And what that means is that the probability of getting a number to the left of the point we tested in our formula, the point we use as x, getting a value equal to that number or less is equivalent to the probability we found on our table. Let us begin with problem 1. Problem 1. The time required to complete a final examination in a particular college course is normally distributed with a mean of 80 minutes and a standard deviation of 10 minutes. Before we begin, let's highlight the important information the problem gives us. They tell us the mean is 80 minutes and the standard deviation is 10 minutes. What that means is we have the standard deviation needed for our formula, which is equivalent to 10, and we have the mean, which is equivalent to 80, and we also know that the mean splits our distribution exactly in half at a point of 80. Now we could begin with A. What is the probability of completing an exam in 1 hour or less? So the first thing we have to do to solve A is to realize that since our distribution is in minutes and our question is in hours, we will translate the hours to minutes. 1 hour multiplied by 60 minutes in an hour gives us 60. And now the question is asking us for the probability of completing an exam under 60 minutes, given that it takes an average time of 80 minutes to complete the exam. So we will add 60 to our distribution, and now we will use our z-score formula. Our z-score formula is equal to x minus the average divided by the standard deviation. We now have all our values, so it would be 60 minus 80 divided by 10 to give us a value of -2. You would have to look up -2 on the z-score table and it would give you a percentage equal to 0.0228, which means the probability, or the area to the left of the point we tested, is equivalent to 0.0228, and it answers our question by stating that the probability of completing an exam in less than 1 hour is equal to 0.0228 or 2.28%. And on the exam, you would write that in a sentence. Before we begin B, we're going to recopy our standard deviation and our mean from the previous question. Our mean was 80 and our standard deviation was 10. Now we can begin. What is the probability a student will complete the exam in more than 60 minutes but in less than 75 minutes? This question is asking us for the probability in between 2 points, so the simplest way to solve that is to handle each point separately and then find the difference. We will begin with less than 75 and we will solve it on our first graph. We know our mean to be 80, and we're looking for the probability of a student taking less than 75 minutes. All we have to do is plug it in to our z-score formula, which would give us 75 minus 80 divided by 10 to give us a z-score equivalent to negative 0.5. We would look that value up on the table and it would equal a probability of 0.3085, which means the probability of a student taking less than or equal to 75 minutes to complete the exam is equal to 0.3085. Now we can move on to the second part, which is more than 60 minutes. We're going to apply the same steps. Our mean is still 80. However, now we're looking for the 0.60. Again, using the z-score formula, we're going to plug in x, or 60 as our x, minus our mean of 80, divided by our standard deviation of 10, to give us an answer of negative 2. We will look up negative 2 on the z-score table, which will give us a probability of 0.0228. We're going to highlight that area on our graph, and it means that it would take the student, or 0.0228 of all students would complete the exam in less than 60 minutes. And since the problem is asking us for the area in between 60 and 70, which would be highlighted on our third chart, all we would have to do is subtract our two probabilities to give us the area in between. So 0.3085 minus 0.0228 gives us a value of 0.2857, which is the highlighted region on our graph. And it means that the probability that a student will complete his exam in more than 60 minutes but less than 75 minutes is equal to 0.2857 or 28.57%. And on your exam, you could write that in a sentence. C. Assume that the class has 60 students and that the examination period is 90 minutes in length. how many students do you expect will be unable to complete the exam in the allotted time? This question is asking us for what's the probability that a student will take 90 minutes or longer to complete the exam. Since we're dealing with the same problem, our standard deviation, our mean is still 80, and our standard deviation is still 10. We will add the mean to our graph, and the question is asking us for longer than 90 minutes. So this area. We'll begin by plugging in our values into the z-score equation, which would give us 90 subtracted by 80 divided by 10 to give us a value of 1. We would have to look up 1 on the z-score table, and that would give us a value of 0.8413. However, the key thing to remember is the z-score table always gives you the probability to the left of your value, meaning that this entire region is equal to 0.8413, but we're looking for the other side. However, since we know that in probability the entire graph is equal to 1, we could simply take 1 subtracted by the probability of a student taking less than 90 minutes to find the probability of a student taking more than 90 minutes, which would give us a value of 0.1587. And that is the probability of a student taking more than 90 minutes. However, since the question is not asking for the probability, but rather the number of students out of 60 who would fall into that category, we simply take the number of students, 60, multiply it by the probability of them taking more than 90 minutes, and that would give us an answer of roughly 9.5. However, since you can't have half a student, we're going to round up to 10, and on the exam, you would write a sentence saying that we expect 10 students to be unable to complete the exam. Problem 2. The length of time required to complete a small business income tax form by a professional tax accountant is approximately normally distributed with a mean of 4.5 hours and a standard deviation of 0.6 hours. The accountant has 80 small business tax forms to complete. Before we begin the problem, we're going to highlight the important information the problem gives us. It tells us that the mean is 4.5 hours and the standard deviation is 0.6 hours. The accountant has 80 forms to complete. We'll write down our mean on the side as 4.5 hours and our standard deviation as 0.6 hours. A. How many of them will take more than 4 hours to complete? We know our mean to be 4.5 hours and our x value in this case is 4. The problem is asking us for the probability that it will take longer than 4 hours to complete. We'll begin by inputting our values into the z-score formula, which would be 4 subtracted by 4.5 and divided by 0.6, which gives us a value of negative 0.833. We would look up that value on the z-score table to find the probability of 0.2033. However, the z-score table always gives you the probability to the left or less than the x value. So we now know that this part of the graph is equivalent to 0.2033. But we're looking for the other part. Since we know that the entire graph is equal to 1, we can simply take 1 subtracted by the probability of it being less than 4 0.2033, and that would give us 0.7976, which is this part of the graph. And it is what we're looking for. It would be 0.7967 or 79.67%. However, the question's asking us for the number of forms and not the percentage. So what we have to do is take the total number of forms he has, which is 80, multiplied by our percentage, which is 0.7967, to give us roughly 63.7 forms, or round up to 64 forms. And on the exam, you'd write a sentence stating that it would take, or out of the 80 forms, roughly 64 forms will take longer than 4 hours to complete. B. At least how long would it take to complete a form that is one of the 10 most time-consuming forms to complete? Before we begin, we know that we're dealing with the same problem. Therefore, our mean is still equal to 4.5 hours, and our standard deviation is still equal to 0.6. The key to understanding this question is understanding that our z-score formula works around the idea of probability. Therefore, if we understand that, we need to translate this number, 10 of the most time-consuming forms, into a probability. So we will take 10 divided by the total number of forms, which was 80, to give us a probability of 0.125. We're going to add that to our graph. We don't know this value, but we know the area to the right or greater than that value is 0.125. And what we're trying to do is we're trying to get a z-score from that value. However, since we know that z-scores always gives the probability to the left, we would first need to find the probability to the left of that point. Since we know the entire graph is equal to 1, we will simply take 1 minus the probability to the right of our point, 0.125, to find the probability to the left of our point, which is 0.875, and that is equal to this part of the graph. And now that we have that probability, we can translate this percentage into a z-score by looking it up on the inside of the graph and finding matching z-score, which would give us a z-score of 1.15. And now that we have that point, we could use our formula to work backwards to solve for x. Since we have the z, we have our standard deviation, and we have our average, we simply have to isolate x. To do so, we will begin by making 1.15 equal to x minus the mean of 4.5 divided by the standard deviation of 0.6. We will multiply both sides by 0.6 to give us 0.6 multiplied by 1.15 equals to x minus 4.5. We will add 4.5 to each side to give us 0.6 multiplied by 1.15 plus 4.5 equals to x, to find out that x is equal to 5.19. And on the exam, you write a sentence stating that it would take 5.19 hours to complete one of the 10 most time-consuming forms. C. If a form takes longer than average to complete, what is the probability that it will take longer than 5.1 hours? The key to understanding this question is in the first part. If a form takes longer than average to complete, this can be restated as given that it takes longer than average to complete, which is hinting towards the fact that it is a conditional probability question. The rule for conditional probability is as follows. The probability of A given B is equivalent to the probability of A intersection B divided by the probability of B alone, B representing longer than average, and A representing, in this case, longer than 5.1 hours. And since we're dealing with the same problem, our mean is still 4.5 and our standard deviation is still 0.6. Now we can begin. First, we need to find our B and A separately. We'll begin with B. B is simply asking us for the probability that it will take longer than average. If our average is 4.5 hours, the probability of it being to the right of that number is simply 0.5. Since we know our graph is 1 and all, and in the middle it is split to 0.5 and 0.5. However, if you wish, you could solve it mathematically by using the z-score formula, which would look something like this. 4.5 minus 4.5 divided by the standard deviation gives us a value of 0, and a z-score of 0 is equivalent to a probability of 0.5. Now we would need to find the probability for A, a form taking longer than 5.1 hours. 5.1 minus 4.5 divided by 0.6 gives us a z-score of 0.8413. However, as we know, the z-score formula always gives us the probability to the left, which includes this entire part of the graph, which is equal to 0.48 or 8413, which is not what we're looking for. However, since we know the entire graph is equal to 1, we can simply take 1 subtracted by what we're not looking for to give us a probability of 0.1587, which is this part, which means there is a 0.1587 or 15.87% chance of any given form taking longer than 1.5 hours. And since we're looking for the conditional probability, all we have to do is take the probability of A alone, which is technically still the intersection of A and B, since if it takes longer than 5.1 hours, it also takes longer than the average, which is 4.5 hours, divided by B, which was 0.5, to give us a probability of 0.317 or 31.7%, which means there is a 31.7% chance that a form will take longer than 5.1 hours, given that it takes longer than the average. And on your exam, you could write that in a sentence. Problem 3. The length of a metal rod produced by a manufacturing process is normally distributed with a mean of 140 millimeters and a standard deviation of 0.2 millimeters. A. Compute the probability that a randomly selected rod is longer than 104.5 millimeters. Before we begin the problem, we're going to highlight the important information the problem gives us. It tells us that the mean is 144 millimeters and the standard deviation is equal to 0.2 millimeters. We'll write those numbers on the side. And now we can begin. The problem is asking us for the probability that a rod is longer than 140.5 millimeters. If we know our mean to be 140, our x value is to the right since it's greater than 140. And we're looking for this probability. we'll begin by putting in our numbers into our z-score formula, which would give us 140.5 minus 140 divided by 0.2 gives us a z-score of 2.5. We will look up that value on the z-score table to give us a probability of 0.9938. But since we know the z-score formula always gives us the probability to the left, this area is equivalent to 0.9938, and we're looking for this side. Since we know the entire thing is equal to 1, we will simply take 1 subtracted by the probability of what we're not looking for, which is 0.9938, to give us 0.0062. And that means the probability for the area we're looking for is equivalent to 0.0062, or 0.62%. And on the exam, you would write a sentence stating that there is a 0.62% probability that a randomly selected rod will be longer than 140.5 millimeters. B. Compute the probability that a randomly selected rod is between 140.2 and 140.5 millimeters. Since we're dealing with the same problem, our mean is still 140 and our standard deviation is still 0.2. And the problem's asking us for the probability between these 2 points. So we'll begin with this point. Since we know that our mean is 140 and our x is 140.5, we will plug in our values into the z-score equation to give us 140.5 subtracted by our mean of 140 divided by our standard deviation of 0.2 to give us a z-score of 2.5. We will look up 2.5 on the z-score table, and that will give us a probability of 0.9938, which means the entire area to the left of our x value is equivalent to 0.9938, which we will quickly shade in. Next, we have the point which is 140.2 with the same mean. So we will repeat the process, which will be 140.2 minus 140 divided by the standard deviation of 0.2 to give us a z-score equivalent to 1. We will look up 1 on the z-score table, and that will give us a probability of 0.8413, which means the area to the left of that point is equivalent to 0.8413, and we will quickly shade that in as well. And now, since the question is asking us for the point in between, or the probability in between these 2 points, the points being 140.2 and 140.5, we simply take our answers from above. As we know, the probability of it being less than 140.2 is equivalent to 0.8413, and the probability of it being below 140.5 is 0.9938. To find this middle section, all we must do is subtract the two values, 0.9938 minus 0.8413, gives us an answer of 0.1525, or 15.25%, which means there is a 15.25% chance that a randomly selected rod will be between 140.2 and 140.5 millimeters. And on the exam, you would write that in a sentence. C. A rod is considered defective if it is less than 139.8 millimeters or if it is longer than 140.2 millimeters. compute the probability that a randomly selected rod will be defective. Again, since we're dealing with the same problem, our mean is still 140 and our standard deviation is still 0.2. And in this case, the question is asking us for either less than 130.8 or 139.8 or greater than 140.2. So we will do it one step at a time. We will begin with less than 139, since we know our mean to be 140, and we're looking for less than 139.8. We will simply plug in our values into our z-score equation, 139.8 as our x, 140 as our mean divided by our standard deviation of 0.2, which gives us a z-score of -1. We will look up -1 on the z-score table, and it will give us a probability of 0.1587, meaning that this area of the graph is equivalent to 0.1587. Now we can move on to the second part of the problem, which would be longer than 140.2. Again, we will just plug in our values into the equation, 140.2 for our x minus 140 for our average divided by our standard deviation of 0.2 gives us a z-score equivalent to 1. We will look up 1 on the z-score table, which will give us a value of 0.8413. But again, remember that the z-score table always gives you the probability to the left, which means this entire section here is equivalent to 0.8413. But we're looking for this other side. So since we know that the entire graph is equal to 1, we will simply take 1 subtracted by what we are not looking for to give us 0.1587, which is what we are looking for. Now, since we're looking for either scenario, we simply recopy our scenarios on our third graph to give us that the probability that a randomly selected rod is under 139.8 millimeters is equivalent to 0.1587, and the probability that a randomly selected rod is longer than 140.2 millimeters is equivalent to 0.1587. And since we're looking for either case, we simply add up the probabilities to give us a final answer of 0.3174 or 31.74%. And on the exam, you read a sentence stating there is a 31.74% chance that a randomly selected rod is less than 139.8 millimeters or longer than 140.2 millimeters. D. In a sample of 15 rods, compute the probability that there will be no defective rods and the probability that there will be exactly 5 defective rods. This question is very similar to something we would see in chapter 5, which is a binomial question, since a rod is either defective or it isn't. And since we're dealing with if it's defective and we're basing it on the previous probability, we will simply recopy that probability, which we found in C. The probability of a rod being defective was equal to 0.3174. We will begin with I, where there is no defective rods. We know our N to be equal to 15, our X to be equal to 0, our P to be equal to 0.3174, and 1 minus P to be equal to 1 minus 0.3174, which equals 0.6826. And this could also be denoted as Q. Now that we have all our variables, we're simply going to plug it into the equation. 15 factorial over 0 factorial multiplied by 15 factorial multiplied by 0.3174 to the power of 0 multiplied by 0.6826 to the power of 15 gives us an answer of 0.0033 or 0.33%, which means there is a 0.33% chance that no rods will be defective out of the 15. And now for I, we will repeat the steps. The only difference is that our x will now be equal to 5. So we will begin 15 factorial divided by 5 factorial multiplied by 15 minus 5 factorial multiplied by 0.3174 to the power of 5 multiplied by 0.6826 to the power of 10 gives us an answer of 0.2110 or 21.1%, which means there is a 21.1% chance that exactly 5 rods will be defective out of the 15. Problem 4. COMM Incorporated is in the midst of a cost-cutting drive. One of the possible ways of saving money is in paper use. The amount of paper used per week is approximately normally distributed with a mean of 250 kilograms and a standard deviation of 45 kilograms. A. What is the probability that the use of paper in a week will exceed 214 kilograms? Before we begin the problem, let's highlight the important information the problem gives us. It tells us that the mean is 250 kilograms and the standard deviation is 45 kilograms. We will write those numbers on the side. And we also know that the first problem, A, is asking us for the probability that a week's worth of paper will exceed 214 kilograms. So we could begin. A. We know our mean to be 250, and we're looking for the probability that the paper use will be above 214, meaning this area of the graph. We will simply plug in our values into the z-score formula. Since we have an x, we have a mean and a standard deviation to give us 214 minus 250 divided by 45, which gives us a z-score of 0.8 or negative 0.8. We will look that up on the z-score table to give us a value of 0.2119, and that value represents the area to the left of our x value. However, that is not what we're looking for, but since we know the entire graph is equal to 1, we can simply take 1 minus what we're not looking for, 0.2119, to give us 0.7881, which is what we are looking for, this entire region of the graph, which is equal to 0.7881 or 78.81%. And on the exam, you could write a sentence stating that there is a 78.81% chance that in any given week, the paper use will exceed 214 kilograms. Now let's move on to B. COMM has set a target of no more than 200 kilograms of paper will be used in a week. How many weeks out of 52 already meet this target? So in this case, again, our mean is 250, and our goal is to be below 200 kilograms. So we're looking for this area. Since we have all our values, we can simply plug them into the z-score formula with 200 minus the mean of 250 divided by the standard deviation of 45 gives us a z-score equivalent to negative 1.1 and a z-score of negative 1.1 equals a probability of 0.1335. And now the problem is asking us for the number of weeks that meet that goal. So to solve that, we will simply take the probability we found of 0.1335 multiplied by the number of weeks they gave us, which is 52, and that equals to 6.942, or roughly 7 weeks. Meaning that out of 52 weeks, roughly 7 weeks already meet that goal. C. Estimate the 60th percentile in current weekly use. Before we begin, we're going to recopy or rewrite our mean, since that has not changed. It is still 250, and our standard deviation, which is still 45. Now, the key to understanding this problem is being able to interpret the meaning of 60th percentile. If we were to draw the 60th percentile on a number line, it would mean that whatever our x value is, if it is the 60th percentile, 60% of all other values must be below that x value. Therefore, if we interpret the 60th percentile as 60%, we can simply look up 60% on the z-score table, or we would look up 0.6 on z-score table to give us a z-score value equivalent to 0.2533. And now that we have our z-score value, we can check that out from the equation. We have our mean and we have our standard deviation. We can use them to solve for x. So that is what we'll do. 0.2533 is equal to x minus 250 divided by 45. We will isolate x by multiplying both sides by 45 to give us 45 multiplied by 0.2533 is equal to x minus 250. Then we will add 250 to both sides to give us 45 multiplied by 0.2533 plus 250 equals x, and therefore x equals to 261.4. Now to visualize that on a graph, we knew that our mean was 250. We knew we had some sort of x value, which we didn't know, but we did know that its percentage, or the percentage less than that value, was equal to 0.6. And we use the z-score formula to solve for our x, which we know to be 261.40, which means that the 60th percentile of weekly use is equal to 261.40 kilograms. And on the exam, you would write that in a sentence. That is all for this video. Thank you very much, and I hope to see you guys next time.